Well, this number 8, these are the kind we like to see. All we have here is a constant. What would differentiate to give us a constant with the variable x? 3x. And we're going to evaluate that from 0 to 7. So we're going to get 3 times 7 minus 3 times 0. 21 minus 0. This evaluates to 21. Problem number 9 is going to take us a little bit more work than problem number 8. We've got a quotient here, and it's nothing direct, so it doesn't match one of those basic integration formulas. So I've got a quotient. I'm thinking u substitution, and when I have a quotient, I'm going to let u equal that denominator, 2x squared minus 3x. Now let me circle it here so I can see it. Now here's where we are. This is in terms of x, right? X equals 2, x equals 4, but now we're converting to u's. So I'm going to convert these to u's also. So I'm going to say this. When x is equal to 2, u is equal to, okay, now just put the 2 right back in here, right? U is equal to this in terms of x. So I'll put 2 in here. So we are going to get 2 times 2 squared minus 2 times 3. So we'll get 4, 8 minus 6. Well, it still comes out to 2. So when x is 2, u is 2. When x is 4, let's see, u is going to be 2 times 4 squared minus 3 times 4, right? I'm just putting that 4 right back here and here. So this is going to give us 16 times 2 is 32 minus 12. Looks like we'll get a 20 out of that. So here's where we are right now. We're now going, instead of from 2 to 4, we're going from 2 to 20, and we put a u in the denominator, but look, we still have to get that numerator. The numerator is still an x, 4x minus 3 dx. We need to get this in terms of u, and if this is going to work, we know if this is going to work, we're going to have to get that u, the rest of that from up here. So let's take this derivative. So here I'm going to get du, let's use white here. We'll get du is equal to, okay, 4x minus 3, and then if I multiply by dx, well, this is nice, right? Because look what happened. Here's what we have. Here's what we want, right? If I start with my u, this is what I have, this is what I want, and what I have matches identically to what I want. So we can write our integral now as this, from 2 to 20 as 1 over u times, and then what is this? The 4x minus 3 dx? It's right here. It's just du. du. Now, when I anti-differentiate 1 over u, I know where that comes from. That comes from the natural log, so I'm going to get the natural log of the absolute value of u from u equals 2 to u equals 20. Let's evaluate. Put in that upper limit. Natural log of 20 minus natural log of 2. I don't know what this is down here. Now, I could maybe leave it like that, but I noticed this. The 20 and the 2, these are both positive, so I don't need the absolute values anymore. So how about just natural log of 20 minus natural log of 2, and because I have these rules of logarithms, when I have a subtraction, I know that comes from a division of a single log. This is the natural log of the first minus over the second, and that just happens to reduce to the natural log of 10.